With this in our notes, so you have this, you can go back. I'll erase the homework here so I have room. Okay, so where were we? I needed to shade this. So because of the y-x and the y-intercept being 0, that means that 0, 0 is for sure a point, so you need to find a second one. And that's just strategic, right? You just pick one within your graph. Don't make it be outside, right? You got to be within. So we had to graph. Did we determine the shading for that one? I didn't. You might have. So solid, true is below because it's less than. And so we're going to shade above. Okay. I'm going to use my ruler to help me out. So I'm taking that diagonal there, and I'm going to shade everything above it. Okay, so that's gone. I'm going to my vertical, and I'm supposed to shade to the right. So I will just do a light shading here, just like this. See where this is going. Okay, that's gone. And the other one, I'm told to shade above. So if I shade there, I can tell that this is going to be my solution region. So then I'm okay. At least you have a solution region. You don't want to get to a point where your solution region is all shaded. Like the whole thing is shaded, like something isn't right. So now I'm going to go ahead and commit to this and just shade it all in. Okay. And your labels, you know what? I must say you're pretty good at that. You're pretty good at that. So I'm still going to remind you from time to time. So that's my solution polygon. Okay. So I have 1, 2, 3, 4 corner points or points of intersections. Read, read, read. This one is easy to read. So only really one that I need my calculator for. Okay. So I'm supposed to state them there, but I'm just gonna say points of intersection. I'm gonna do that down here. By the way, I'm fine with that. If you ever write a test and you say, hey, POI is way over here, as long as you label it clearly, I'm fine with that. As long as it's on that page. But don't just make them appear and not label them, right? So I'm gonna go and say, wait, yeah, that's okay. 0, 0. Include that even though it's redundant, right? Like it doesn't really make much sense. This one here is 750, right? So 750, 0. And then up here I've got 750, 250. And the one I need to find. It's probably not going to be there anymore, is it? No, it's gone. So it's 1/2 x, and the other one is 250. Let's see if it finds it. There it is, 500, 250. So read, 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 calculator. Because if you do everything with a calculator, it's going to take you it's going to take too long, right? So if you can shave off some time, do it, okay? Anyways, let's go back to what this question is asking. If cheese costs 65 per 100 grams, pepperoni is 85 cents per 100 grams, determine the objective function. And this one should be for cost, right? To be very specific, because they could say there could be an objective function on grams used to make a pizza, right? In this case, it wants the cost, right? So there's a bit of a problem there. What are my units in? Like if I look at the graph here, it's all in grams, right? And they're giving me the cost per 100 grams. It's a bit of a problem, but not a big problem. We can handle that. So we really will just say 65 cents per 100 grams. If you divide that, it's 0.0065 dollars per gram. I know it's ridiculous, but if you go with bigger amounts, it will make sense. Okay, so we have that, and this just turns out to be 85 cents per 100 grams. Remember unit price, right? The unit rate, that's all I'm doing here per grams. And I'm just going to highlight the reason I'm doing this is because I need everything to be in grams because I'm talking grams. It's almost like hours and minutes, right? You want to have everything in the same unit, right? So for cost, it's 0.0065 per. I'm just making sure that my pepperoni, my cheese, read carefully. So it's 65 cents per 100 grams of pepperoni. What's pepperoni up there? Y. So you know what? I'm going to stick with X and Y. So I'm just going to make this 85X plus 0.0065Y. Okay? Just to make sure I have X and then Y. So this is it. Yes, it's okay to have the dollar sign in front of it. I'm okay with it. That is the objective function there for cost. Sometimes it's a separate statement. Sometimes it's in the main paragraph that you're given, these coefficients, right? So you just have to read and go by that. Determine the combination that would minimize the cost of producing a pizza. In my notes, I told myself to give you more space for the graph up there. I just see it now, but hey, next time. Yeah, so obviously to minimize the cost, 0, 0 is not to be considered. You are a business, right? You want to produce, you want to sell, because if you're not selling, you're right. Like if you're not making any pizzas, you're not going to be in the business for very long. Okay, so we're not going to consider 0, 0 here. So we just plug in 750, 0, for example, into the cost equation. So it's 0.0085 times 750. We have 750, 250. Cost is 0.0085, 750 plus 0.0065, 250. And then you have 500, 250. Plug that into your cost. Let's scroll up a bit. Is that like Lord of the Rings or something? Sorry, I'm not into the latest shows, so I probably missed it. 8. Why did I circle that? Sorry. Am I, is that the answer? That's probably the answer. Five. Oh no. We have a winner here. This is just to trick you. Yeah, why is he doing that? Today's my off day. Okay, 588. That would be the best option, right? Using 500 grams of cheese and 250 grams pepperoni will minimize cost. Done. Okay, we're gonna do the second one on page 17. Yeah. After cheese and. Yeah, it doesn't look like it, but I promise you it's standing for and. It's my cursive kicking in. All right, can you read 17? Oh, can you read 17 and come up with the inequalities? And some of you probably have it done already. Page 17. Page 17. Read it. Come up with the inequalities. I won't tell you how many there are. Some of you looked at, maybe you tried it already. We've done something like this with jobs and stuff. So, but the good stuff is not recorded. Okay, 1250 x is equal to 345. You divide both sides by 1250. And where you go. That's 27.6. No rounding. It's just 27.6 like that. 0. And with the y-intercept, x is equal to 0, so all of this goes. You're just left with 14.25y is equal to 345. Divide everything by 14.25. Y is equal to 2421. All right. And now you rewrite it. Let's hope I can make that work here. 1425 y is greater than or equal to 1250 comes over negative x, and there's the 345 is already there. You divide everything, so we're just going to go ahead and say it's negative 1250 over 14.25 x plus, this is not a very pretty equation, but we can, because of calculators, we can make it work no problem. Right? Can you imagine graphing that in IPR? Good luck, right? So we have that as our equation. We know that it's solid. The true region lies above because it's greater than. So we will shade the opposite, we will shade below it because we want only the true region to remain for all of our inequalities. Good? Your homework will be to come up with an inequality for your time. I have only this many hours a week. Mr. Dirkson's class takes up at least 4 hours a week. Okay. Hours pumping gas. I want at least 20 hours of screen time. Call center. Sorry, it says call center there, trust me. So I'm just going to leave it at that. And my scales are going to be determined by what I have, right? So x-intercept is 27.6. I am going as far as 45. So if I go 50, that should be fine. So 10, 20, 30, 40, 50, and one more just for good measure. Right? And then my y-intercept, I'm going, I have 24 here, but I do have 45 still. So I'm going to do the same thing. 10, 20, 30, 40, 50, and 60. That'll do the trick. So let's do the 45s. Both 45s should be simple. I'll label it a little bit later. And then I have the Y20. That's a dashed line. Go ahead. And then I have 27 is right about there. And 24 is right about there. That's a solid. And let's not forget to label now. So this is my x plus y is less than or equal to 45. This one, I'm just going to write this form of it. Okay. And so this one, it says to shade above. This one, it says to shade below. And the horizontal, I have to shade above. And so my solution region is there. I have 1, 2, 3, 4 corner points, 2 of which are easy to read. How about we write them down here? POIs. I'm going to write the 27.60. Then there's the 45.0. Can I leave 27.6? It's hours, right? Even though in real life, but we don't do real life in school, right? We just, I'm just kidding. It's just, if you did round, I think I personally wouldn't take off as long as you have the decimal there. Okay, let's go find those. And this is the reason why I'm going through the whole thing is because that way you have an idea of how long it takes, right? It does take a while. It does take a while. 14.25 x plus, so this is how I enter it, right? I enter the whole thing. And the other one is the 20 line. And my scale is way off. So I'm going to go, I usually just go -2 and then go up to 50, -2, go up to 50. That's better. What about the other line? Wait, at 4.820. Now I'm going to enter my other diagonal line, which is the -x plus 4.5. Second trace 5. Jump to the black one, enter. Jump to the red one, enter. And that ends up being 2520. Calculator, calculator. Read, read. All right. Write the objective function to calculate the total income. Income is 1250x plus 1425y. That's it. Not to be graphed, no inequalities, just there could be a question saying write the objective function that would tell you the total number of hours you've worked, right? So just that would in this case just be x plus y. Okay. So just watch out for what it says after you read objective function. What would be, which combination would result in the maximum income? So you want the greatest output, right? In this particular case. And we'll do that. Okay, so there we go. 27.60 goes into I. It's 1250 times 27.6. 450 goes into I. That's 1250, 45. 4.820 goes into I. It's 1250, 4.8 plus 1425 times 20. 2520. $345. $562.50. $345 again. $597.50. So the winner is this one here, right? Now, I know what some of you are thinking. If you were paying close attention, there's a bit of a problem here. What this line here, like the intersection here, lies on this dashed line. Okay? And my answer is going to be forget about it. Don't worry about it. Just continue. Because I will not do this. I will not do this to you on a test or whatever. I just wanted to for you to see that. Wait a minute. Like read carefully. It's not always solid lines. Okay. That was the only purpose I put that in there. It gets too complicated when we basically what you would do is bring it down to 19, right? In real life, but we don't do real life. Remember, you just bring it down to 19, and then you're good, right? Then you'll be in the solution region, or 19.5 or something like that. But I'm not going to go there. That's not. We're not going to do that. So working 25 hours pumping gas and 20 hours at the call center will result in maximum income. And now you know why I had to resubmit my essays all the time. Teachers couldn't read my writing.